Hi, welcome to my video on review number 2, right triangular trig, and the videos are the review of numbers 10 to 12, and it's the word problems. And as all reviews, we have treated as a quiz. So this quiz, it has marked to have a total of 25. So we have one. This is the first page, 1 of 5. We have 4 more pages and X number of problems to do. I think it might be 7 problems. So what you can do is pick up at least 4 blank sheets and work out the problems ahead of time. And then when you get them done, click play to see if you got it right and give yourself a score on each question. And you can total the bottom of each page when you get them all done, add up the total and put it over 25. Here we go. Review of word problems. A person on the ground observes a plane at an angle of elevation of 27 degrees. If the plane is 1,500 meters from the person, find the altitude of the plane to the nearest tenth of a meter. So what we have is, if you think about it, we say this is the ground, and a plane is in the air, so let's pretend that the plane is up right here. And a person on the ground is looking up at the plane. So this is the angle of elevation of 27 degrees. And the plane altitude is straight down to the ground, forming a right angle. So this is the altitude from here to here. And it says if the plane is 1,500 meters from the person, so there's the person on the ground looking up at the plane, and you're getting the angle of elevation. And it says find the altitude of the plane. So the altitude is, I'm going to call it x, to the nearest tenth of a meter. So we're using trig, so sine is opposite over hypotenuse, cos is adjacent over hypotenuse, tan is opposite over adjacent. So in this angle, this is opposite and this is hypotenuse. So opposite and hypotenuse is going to be opposite over hypotenuse is sine. So we have the sine of 27 degree angle is opposite, which is x, over 1,500 meters. So put it over 1, cross multiply. 1 times x is x, and we get 1,500 multiplied by the sine of 27. So we bring our calculator into play. Here comes the calculator. And we have it cleared. So we have 1,500 sine of 27 degrees. And that gives us 680, and we want it to the nearest tenth. So 6,809. So since this is an 8, we add 1 to the 9 to get 0. So that gives us a 10. So we add 1 to here. So it's 168. Or sorry, 681. And it's in meters. So it's to the nearest meter. So 681 meters. And if you have the diagram drawn, you get 1 mark. If you have this ratio right, you get a mark, and if you get the final answer, you get another mark. So 3 marks altogether. Let's move the page up. And here we go. And we have another problem to do. So a pole 9 feet long has a wire attached at the top. The angle between the wire and the top of the pole is 42 degrees. How long is the wire to the nearest tenth of a foot? So we have a pole. There's the pole, and the pole, and we have the ground. Okay. G-R-O-U-N. Don't spell that ground, but it's G-R-O-U-N-D. So here's the pole. The pole is perpendicular to the ground, and the pole is 9 feet long, has a wire attached at the top. Okay, so there's attached at the top. Find the angle, the wire, and the top of the pole. the angle between the wire and the top of the pole. So there's the top of the pole, there's the wire. So the angle between the wire and the top of the pole is 42. How long is the wire to the nearest tenth of a foot? So there's x. And we want to find what x is to the nearest tenth of a foot. And sine is opposite over hypotenuse, cos is adjacent over hypotenuse, tan is opposite over adjacent. So in terms of this angle, this side is adjacent, this side is hypotenuse. So adjacent over hypotenuse is cos. So the cos of 42-degree angle is adjacent, which is 9 over x. And we put it over 1, cross multiply, x cos 42-degree angle. 1 times 9 is 9, so x is 9 divided by the cos of 42 degrees. So we'll clear this on our calculator, move this up a little tiny bit more so you can see. So we have 9 division cos 42 degrees, and that gives us 12, and to the nearest tenth of a foot, so it's 12. Tenth, the 1 is in the tens place, this is less than 5, so it stays as 12.1. And it's in feet, so the length of the wire is 12.1 feet. And again, if you have your diagram drawn correctly, give 1. If you have a ratio, give another. If you get the final answer worked out, you have another. So you got your scores done, total your page. And so let's bring the sheet down, back in line, and let's do some more problems. Number 3. From the top of a 200-foot tower, a forest ranger sights 2 hunters at angles of depression of 40 and 30. Find the distance to the nearest foot between the hunters. Let's make that an S, between the hunters. The hunters are in the same line of sight. So let's pretend that this is the tower, and the top of the tower is here. So this is, the tower is perpendicular to the ground. Here's the ground. So if the forest ranger is looking out, straight out, then he's looking at that angle. And he looks and he observes 2 hunters on the ground. So one hunter is right here, and the other hunter, pretend, is right here. So if I draw a line between, pretend these lines are the line of the sight of the ranger. Forest ranger is looking down at this hunter, and he's looking down at this hunter, and he spots the 2 hunters. The angles of depression are 40 and 30. Now, what happens is that if you depress your head here, you get this angle of depression is 30. And if you do this, this angle is 40. Notice this is a smaller drop, so you're less. And if you go down here, that means that if this line is parallel to this side, 2 of these lines are horizontal, so that's 30. This angle is 30 right here, because alternate interior angles are equal. If this angle is 40 right here, and this is transversal, this angle is 40. So alternate interior angles equal when your lines are parallel. Notice also that if you're up on the hill looking down, the further out you go, the further out here you go, the smaller the angle is, the less you got to drop your head. If you're in closer to the tower, then you got to drop your head more. The angle right here, you draw that line right there, this angle is going to be bigger. So the closer you get to the tower, the steeper the angle is, the more you got to drop your head. And it says find the distance between the hunters. So what we do is draw 2 triangles. So let's draw that one. And let's draw you can draw the big one, you can draw the small one, makes no difference. So we say that's 30 with a right angle, and you say that's 40. So let's label A, and this is the forest ranger F, and the right angle. So right here we have, that's A, that's the forest ranger, and right here, this one, if you call that one B, there's B, and the forest ranger, and we have a right angle. So we could call a right angle any letter X. So that's an X, and that's an X. So the tower is 200 meters high. So 200 meters is here. So that means this height of, this is the tower. So that's 200 in this triangle. And this is 200. And so there's the two triangles. FXB. FXB is this one with the 40-degree angle. And FXA is this big one right here with the 30-degree angle. Find the distance between the hunters. So the distance between the hunters is the difference in, so if I got XA, which is the big long distance, A is the furthest hunter away, and XB is the hunter that's closer. So the difference between these two, XA and XB, is the difference between the two hunters. So let's call this hunter X, and let's call this hunter Y. So in this triangle, I have the angle that's opposite, and that's adjacent. So I have opposite over adjacent, so I have a tan. And just sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. So we have tan, so we have the tan of the 30-degree angle. Tan is opposite, which is the 200 over the adjacent. Put it over 1. And so x tan 30 degrees, 1 times 200 is 200. And we divide x is 200 divided by the tan of 30. And I'm going to move this up a little bit so you can see me manipulating the calculator. Here I go. I turn the calculator on and clear. So we have 200 division tan 30. So 200 division tan of 30 degrees. And that gives us 346. And we want it to the nearest foot. So it's 346.4. So closest is 346. So 3, 4, 6. And the distance is in feet. Okay. Now let's deal with the other triangle. And we have, again, this is opposite and this is adjacent. So we have the same tan opposite over adjacent. So the tan of the 40-degree angle is opposite 200 over adjacent, which is y. Put it over 1. So we got y tan 40 degrees. 1 times 200 is 200. So y is equal to 200 divided by the tan of 40 degrees. And so we clear that. So 200 division tan 40 equals to the nearest degree. So that's a unit is 8. This is less than 5, so we don't change 238. So 238 feet. So the distance between the hunters, the furthest hunter away, so the distance between the hunters is 346, subtract 238. And just to make sure we're going to do okay, so 346 subtract 238. 346 subtract 238 is the distance between the two hunters is 108 feet to the nearest foot. Again, notice we need two right triangles here because you had two different angles of Notice this angle of depression is equal to the angle of elevation in both cases. Okay, number 4. Here we go. The slope of a ramp is 0.15, decimal 15. Find the nearest degree of the angle between the ramp and the ground. Okay, common problem. The slope of a ramp. Well, let's explain. The slope. Let's draw a ramp first. So let's pretend there's the ground. A ramp is leaving and coming up from the ground. And the ramp is so long, it could be leaning against a house. It could be a wall going up to a building with a doorway. And the slope of the ramp, this is the length of the ramp. We want to find the angle between the ramp, which is this, and the ground here. So we need to find this angle right here. And this is the right angle. So how do we go about it? The slope. Well, we know that in slope is a rise over a run. So that means the slope is 0.15. Now, I don't have to change that, but let's change it to 15 over 100. I could leave it as 15 over 100. 5 into 15 goes 3. I could make it 3 over 20. So, if we make it 3 over 20, so slope is rise over run. So that means the rise is 3 and the run is 20 when you reduce it. So the rise is 3 and the run is 20. Now you could have left 15 be the rise and the run be 100. It makes no difference. You didn't have to reduce it. You could have let it stay as 0.15. It makes no difference, as I'll show you in a minute. So that means that in relation to this angle, this is opposite and this is adjacent. So really, opposite over adjacent is tan. So the tan of this angle, so think about it, the tan of the angle is rise over run. So the tan of x is 3 over 20. Or, let me move my calculator away here now. I could have said the tan of x is 0.15. I could have said the tan of x is 15 over 100. Any one of these will still give you the same answer. So let's go back. Let's work on either one of these. Let's work on 3 over 20. So angle x is equal to tan to the -1 of 3 over 20. So angle x, clear the calculator. We have to get the angle, so I have to use second function, tan. And I got to use 3 division 20. And that gives us the angle is, and I want the angle to the nearest degree. So 8.5 gives me a 9 degrees to the nearest degree. Because this is a degree, this is 5 or greater, so we add 1 to 8. So the angle of inclination of the ramp is 9 degrees. And again, just to show you, if you did this one, you would have x is inverse tan of 0.15. So inverse tan of 0.15 still gives you the same answer. If you did 15 over 100, you still get the same answer. And the score, let's go back to question 3. I didn't give you the scoring. If you drew these two diagrams gives you 1 mark. This one gives you 1 mark. This gives you 1 mark, and subtraction. So there's 4 marks for this question. You might get the diagrams drawn right, but not do these correctly. So judge yourself accordingly. And number 4, I have 3 marks. So if you drew the diagram, you get 1 mark. If you did the ratio, you get another mark. If you get the answer, you get another mark. So 3 marks. So 7 altogether. Okay, let's continue on to the next page. And we have a triangle ABC has angle C is 90, BC is 14.3, and angle ABC is 51. Find the area of the triangle to the nearest tenth of a square centimeter. So we have a right triangle. It says angle C, so there's angle C to be a right angle. Now I can go A, B, or I can put an A here, B there, A here, B there. So let's put A here and B here. Makes no difference. BC is 14.3. BC is 14.3 centimeters. And the angle ABC is 51 degrees. So this angle is 51 degrees. We want to find the area of the triangle. So the area of the triangle is half the base times the height. So we have a half. The base is 14.3, but we don't have the height. So we leave that for a second. So how do I get the height? Well, I'm going to put, instead of putting an H in here, because it's confused with hypotenuse, I'm going to put X for the height. AC is X. So I use my trig. So 51 degree angle, this is opposite. This is adjacent. So sine is opposite over hypotenuse. Cos is adjacent over hypotenuse. Tan is opposite over adjacent. So I have opposite and adjacent. So opposite and adjacent is tan. So the tan of the 51 degree angle is X over 14.3. Let's put it over 1. So 1 times X is X. 14.3 tan 51. And bring my calculator back in. And we clear this. So I get 14.3 tan 51 degrees. Notice that's understood to be a multiplication between these two. And that gives me 17, and I want it to the nearest tenth. So 17 tenths is 6 is in the tenth place. This is 5 or greater, so I add 1, 17.7. And it's in centimeters. So, okay. Now, I take, since X is the height, so now I put 17.7 into the formula. So I have a half, and I can use my calculator. A half is 0.5, so decimal 5. I could use brackets, or I could use times, so let's use brackets. 14.3 bracket, another bracket, 17.7. Type it in exactly like you see it, and hit the enter button. So the area of the triangle is 1, 2, 6 to the nearest tenth. So there's the tenths. So this is 5 or greater, so that makes that a 6. So 126.6 square centimeter, because area is 2 dimensions. So we worked out that one, and we have 4 marks. So 1 for the diagram, 1 for the ratio, 1 for the height, and then 1 for the final answer. So we have 4 marks altogether, and judge yourself according, give yourself some mark out of 4. And number 6, let's see what we have here. We have a triangle, two right triangles, notice. It says find X to the nearest tenth of a degree. So X is an angle, we have to find the angle. So to get the angle, we have a right triangle. So just label this, let me label A, C, B, and A, F, C, so I can distinguish the triangles. So I have angle X in this triangle, but I only have one side. I don't have any more angles. So in order to work this triangle, to get an angle, I need two sides. So I either got to get this side, DC, or this side, AC. So that means I have to look at this right triangle to get the AC. So I'm going to call this side Y. So I'm going to use the triangle and allow me to move my calculator away. So I'm going to draw the triangle AFC. So we have a 41 degree angle, we have a Y, and we have a 16. So I'm going to solve this triangle, get what Y is, and then when I do that, I'm going to reproduce the other triangle. I'm going to draw the other triangle just like it is there. So you can see. So this triangle is ACD. Notice I put my own letters in to help me see what's happening. So I'm going to get AC, the value of Y. X is here. That's 31.7. So once I get what Y is, then I have the two sides. I'm able to find this angle. So let's use this triangle to get what Y is. So I have 41, that's opposite, and that's hypotenuse. And sine is opposite over hypotenuse, cos is adjacent over hypotenuse, tan is opposite over adjacent. So I have opposite and hypotenuse, so I have sine. Opposite over hypotenuse is sine. So that means the sine of 41 degrees is opposite, which is 16 over y, which is the hypotenuse. And I put it over 1 and I cross multiply. So I get y sine 41 degrees. So sine 41 times y, and 1 times 16 is 16. So y is equal to 16 division sine 41. So we'll move this up a bit so you can see. Maybe using the calculator. So we clear this and we get 16 division sine 41. So that gives us 24. We want it to the nearest tenth of a degree, but we want length. So let's go with the length to the nearest tenth also. So 24.4 to the nearest tenth. So the length of that side is 24 point. Now I could go 24.388. The more accurate, the more places I go down here to round it off, the more accurate I'm going to be. But I'm going to go with 24.4 is the length of the side. So let's go back and put 24.4 in this diagram now. So now I'm working on this triangle. So I have 31.7, 24.4, and I want this angle x. So in relation to this triangle, this side is adjacent, this side is hypotenuse. And so adjacent over hypotenuse is cos. So therefore, the cos of angle x is adjacent, which is 24.4 over hypotenuse 31.7. And that means that angle x is cos to the negative 1, 24.4 divided by 31.7. So angle x, I'm going to clear the calculator now and move this up a bit. Clear the calculator. So I have to go inverse. I'm looking for the angle. I have to go second function, cos, and 24.4 division 31.7. Close that off, and I should have my angle. So I want it to the nearest 10th degree. So 39.6 is in the 10th place. So this is 5 is greater, 7 is greater than 5. So I add 1 onto 6 to get a 7. So 39.7. 39.7 degrees is what x is. And in each of these and move my calculator away. I have, let's see, how many marks? I have 4 marks. So if I did this triangle, I get 1. If I work this out, I get 1. If I did this triangle, I get 1. And if I work the final angle out, I get 1. There's 4 marks. Total up your page, and you get a mark out of 8. Hopefully everything is going okay. And I have one more problem to do as a review. Let's see. Number 7. Find angle BAC. So I have to find this angle right here. In this triangle, BAC. Find the measure of this angle to the nearest degree. And again, we're dealing with trig, so I need a right angle. So I have 16.3. I have 16.3 also, because these two sides are equal. So what happens, because these two sides are equal, that means this angle here is equal to this angle. Because if two sides are equal, two angles are equal. If 3 sides are equal, 3 angles are equal. If no sides are equal, no angles are equal. So the 2 angles that are equal are the angles that are opposite the equal sides. Now I still don't have a right triangle. Because these 2 sides are equal, I can drop a perpendicular down from A down to the base. So if I drop a perpendicular from A down to the base, I make a right angle. Because these 2 sides are equal, that means this perpendicular coming down here splits the base. It forms 2 congruent triangles. Just watch. This triangle is congruent to this one. That side equals that side. This angle equals this angle. This angle right here equals this angle. So this triangle here has 2 angles and a side equal. So that's an AAS. These 2 triangles are congruent. So that means these 2 are 6.3 and 6.3, because the perpendicular between these 2 sides bisects the base. Now we have 2 sides. We're able to find this angle right here. So I'm going to call this angle right here Y. So I'm going to take that out so you can see it. Here we go. I have 6.3, 16.3, and I have my Y. So that Y enables to get my angle. So in terms of this angle, this is adjacent and this is hypotenuse. So sine is opposite over hypotenuse, cos is adjacent over hypotenuse, tan is opposite over adjacent. So we have adjacent hypotenuse, and adjacent hypotenuse is cos. So the cos of Y, which is the angle, is adjacent, which is 6.3 over 16.3. So angle Y is cos to the negative 1 of 6.3 divided by 16.3. And I bring my angle back in. Here we go. Sorry, bring my calculator back in. We bring my angle. So I have, looking for the angles, I got to go second function cos and 6.3 division 16.3, and that gives me to the nearest degree. So 67 degrees, nearest degree is a 7, so that's less than 5, so that stays at 67 degrees. So Y is 67. Okay, now let me draw the triangle separately. Let me move the calculator away. Let me draw the triangle different. So I'm going to draw the triangle without all these in. So here's the triangle A, B, C, with these 2 sides equal. So if these 2 sides are equal, and this angle here is 67, that means this angle here is 67, because the 2 angles are opposite the congruent sides. So 67, so angle BAC is the angle we want. So that's 180 minus 67 minus 67, because it's 180 degrees in the triangle. So when we plug all that in, and we clear it, and let's clear it. So we get 180 minus 67 minus 67. So we get the angle we want to get is 46 degrees. And again, let's check it out. Watch. If we take 67, add on, oops, let's clear that. If we take 67, add on 67, add on 46, you should have 180 degrees in the triangle. I could have doubled these and subtracted from 180. You get the same thing. So anyway, that brings us to the end of the review on the word problems. There's certain skills or ideas that I'll try to bring out when I do word problems. Hopefully everything is great here and you're solving. And what you can do now is total up the pages. Oh, right, let's go back. Sorry, just for a second. I forgot to assign the points. So what happens here, if you drew this altitude and set the triangle up like this, you got 1 point. If you drew this triangle, you got another point. If you got this angle right here, 67, you got another point. And if you got the final one, saying these two angles are equal, subtract 180, you got another point. So there's your 4 points. Put your total at the end of the page. Total up all your pages. And when you get the pages all totaled up, put your score over 25. Divide your numerator, divide it by 25, gives you a decimal. Move your decimal 2 places to the right to get your percent on this review number 2. Hopefully everything was okay. And that brings us to the end of this Trig chapter and brings us to the end of the video. If you like my video, click the like button, subscribe button, the notification bell, because there's more videos coming your way. And visit my website, www.mathfullyexplained.com, to find more information about me, my videos, and the content that's on my YouTube channel called Math Fully Explained. Thank you for viewing my video. That's the end of the trig on right triangular trig. And that's the last video. Bye-bye.